Okay, so today's lesson we're going to start talking about triangles. This is very similar to what we've been doing talking about angles. We're going to be doing a lot of the same stuff. We're going to talk about how to classify triangles by their angles or how to name them. This may be something you did in elementary school. Hopefully this is a review. Also, we can classify them or name them by the sides. And then finding a missing angle in a triangle is very similar to finding missing angles when we are doing parallel lines or any of the other complementary, supplementary angles. Okay, so first, classification of triangles by angles. An acute triangle is one where all three of the angles inside the triangle are acute. What does acute mean? Volunteer? Bryant?
Angles are under 90 degrees.
Now? Oh, wait, say that again?
The angles are under 90 degrees.
Under 90 degrees. Okay, I thought you said 190 degrees. Under 90 degrees. Correct. So an acute angle is one that's less than 90 degrees. All of the angles in an acute triangle have to be less than 90 degrees. Okay, the next kind of triangle is a right triangle. A right triangle has exactly one angle that measures 90 degrees. And it's usually given by, they'll put a little square. That square means that it's a right angle. The last kind of triangle is an obtuse triangle. And an obtuse triangle has exactly one obtuse angle. What does it mean for an angle to be obtuse? Kayla?
Be bigger than 90 degrees.
It's bigger than 90. So an acute triangle, all the angles are less than 90. A right triangle has one 90-degree angle. An obtuse triangle has one angle that's greater than 90. Okay, the other way we can classify triangles is by the sides. First kind of triangle is called a scalene triangle. In a scalene triangle, all of the sides are different lengths. And these tick marks on the triangle are just a way to show that these sides are different. So this has one tick mark, two tick marks, three tick marks. It just means they all have a different number of marks, so the sides are all different lengths. It has nothing to do with which side is bigger or smaller. Okay, next kind of triangle is called an isosceles triangle. In an isosceles triangle, it has two sides which are the same length. So you can see the two sides that are marked with a single tick mark because they have the same number of tick marks. Those sides are equal. The last kind of triangle is called an equilateral triangle. An equilateral triangle has all three sides the same length. And you can see each side has just one tick mark, so we know that those sides are all equal. Okay, any questions about this? Okay, we're going to go on and do the next. It's a practice, but we're going to do it together. So when we name a triangle, we have to name it using both classifications. So we have to say what it is according to its angle measures and also what it is according to its sides. Anna, if I were going to classify this triangle with angle measures, what kind of triangle would it be?
Acute.
Acute. So I'm going to write that it is acute. And if I were to classify it by its sides, Angelina, what would I say it is? By its sides. Mm-hmm. Equilateral. So I'm going to call this triangle an acute equilateral triangle. I'm going to use both names. Okay, number 2. Morgan, if I were going to classify this triangle by its angles, what would I call it? Obtuse. And if I were going to classify it by its sides, Trey, what would I call it? If I were going to classify this triangle by its sides, what would I call it? Scalene. So this is an obtuse scalene triangle. Are these terms all in review to you? Have you seen them all before? Okay, good. Good, because we are only spending just today on this. You have to have all of these terms memorized because you do need to know that for going forward. So make sure you take some time tonight if you don't remember these terms to study them and memorize them. Okay, Emma, number 3. If I were to classify this triangle by its angles, what would I call it? You're doing the sides. That's correct. It would be isosceles, but by the angles inside, what would I call it? Acute. So this would be an acute isosceles. Okay, number 4. Let's go for both terms. Max, what would you call number 4? Right scalene. Good. You guys have that right. Right scalene. Okay, any questions about this classification? Okay. Now we're going to talk about interior angles of a triangle. The sum of the measures of the interior angles of a triangle is 180 degrees. So when we add up all 3 angles inside the triangle, the measure of A plus the measure of B plus the measure of C is always going to equal 180 degrees. It's kind of neat. If I were to cut this triangle apart, and I should have brought a triangle so I could have done this for you. If I were to cut each one of these points apart and I stick all the points together, it spreads out and forms a line. Because a line is also 180 degrees. So all the points of a triangle, when you add them together, form a straight line. Okay, so number 1, we can use equations to solve these. You can also solve the easy ones without writing an equation, but we're going to write equations for all of them. So for number 1, all 3 angles need to add up to 180 degrees. So I'm going to say that 26 plus 35 plus x has to equal 180 degrees. Then I'm going to combine like terms. 26 plus 35 is 61. So we have 61 plus x equals 180. Subtracting 61 from both sides gives me x equals 119 degrees. Now, another way you could do it is you could just on your calculator do 180 minus 26 minus 35 and see what you have left, and that should be 119. Okay, but I'm going to show you with the equations because we'll need to write equations for the more difficult ones. Okay, number 2. Bella, can you tell me what the equation is that I would write?
35 plus 65 plus x equals 180.
Okay, combining like terms gives me what?
100.
Good. 100 plus x equals 180, so x is 80. Good. Okay, 80 up degree sign there. Nathan, what would be the equation for the next one?
Oh yeah, no, 58
Mm-hmm.
plus 90 plus x equals 180.
Okay, when we combine like terms, what do we get?
148.
Good. So 148 plus x equals 180, so what is x?
32.
Good. 32 degrees. Okay, any questions about the basic examples? Okay, go on to the next page. Now we have some more complicated examples, more like some of the ones that we did when we were working on the angles. For number 1, what equation would I write? Bryant, when you're finished yelling at it.
55 plus 54 plus x plus 74 equals 180.
Good. What can I do for you? Yes. Okay, now what do I do?
You add 55 and 54
And
and 74.
and 74. I can add all 3. When I add them together, do you know what we get?
$183.
Good. So we have 183 plus x equals 180. Now, when we subtract 183 from both sides, what do we get for x, Brian?
X equals
Negative 3. So we get a negative number for x, and that's okay. We're not saying that the angle is negative. We're saying that x is negative. The measure of this angle is x plus 74, which is negative 3 plus 74. So this is a 71-degree angle. So sometimes you will get a negative answer for x. You will never get a negative answer for an actual angle, though. Okay, let's do another one together. Madison, tell me the equation for the next one.
8x plus 2 plus 7 plus 6
Okay, what would I do first to solve it?
add 16
Okay, what do I get?
134.
Good. So I now have 8x plus 132 equals 180. Now what do I do?
Subtract 180 minus 132.
Okay, now I'm actually going to subtract 132 from both sides. So I end up with 8x equals what?
48.
Good. And then what?
Divide by 8.
Good. And what do I get for x? 6. Good. Okay, any questions? Okay, I would like you to try the next two. So I'm going to pause the video. Okay, so I'm just going to give you the answers for the two of these. I've been around to see a lot of you. Most of you had correct answers. The correct answer to number 3 is x equals negative 7. The most common mistake I saw was saying that x equals negative 14 instead, forgetting to divide. You have two x's. You have to divide by 2 at the end. The answer to number 4 is the same. It's also x equals negative 7. Any questions about how we got those numbers? Okay, moving on, let's look at some of the more challenging examples that combine some of our adjacent and vertical angle properties along with the triangle angle sum properties. Okay, number 1, you have a triangle and you also have what's called the exterior angle of the triangle, which is what happens if you extend one of the lines of the triangles. Does anybody have any idea what we could find first? We need this angle, so you could substitute this question mark with an x. That's what we need to find. There is no way to just find the x directly. We have to find the other angles first. Avery. Okay, subtract 180 and 137, so we can find this angle. What do we get, Avery, for this angle? What did you get? Yes, that's correct. I have one thing written down on my paper. It's 43. Let's see if I can get this in here small. Okay? Then what can you do? So now we know two of the angles of the triangle, so what can we find out? Michael?
180 minus 102.
Well, if we did that, that would give us this angle over here, which we don't need. David, what do you think?
102 minus 90.
102 minus 90. Well, no, because we don't know if any of those angles up there are 90 degrees. Think about what you guys just did with the triangles. Could we find this angle inside the triangle? Would that help us to find that? Yeah, it would help us. How do we find that angle, or what is that angle? Nathan?
102 minus 43.
No? No. How much do all the angles in the triangle add up to?
180.
180. So we need to do, you could write an equation or you could just subtract 180 minus 102 and then minus 43. Okay, we need to find out this plus our missing angle inside the triangle need to equal 180. David? 35. Okay. So 35. So now we have worked our way over to this angle. If we know that this is 35, how can we find x? Trey? Okay, what do we get? Good, 145. So our mystery angle is 145 degrees. Okay, so all of these examples are like that. You have to find one of the other, or several sometimes, of the other angles before you can find the angle you're looking for. So number 2, just to kind of talk you through it, you could find the vertical angle, then you could find the missing angle in the triangle, then you could find the angle on the exterior of the triangle. Okay? Numbers 21 through 24 just give you some more challenging examples that actually have X's in them. So if you can get 1 through 4 here, go ahead and move on and try those. I'm not going to go over all of these right now. Your homework is not, actually, can't remember if it's this tricky or not. It might have a couple of the tricky ones in it. Let me take a look. No, it's just all angles inside the triangle, so we won't have the challenging ones. So we're going to stop here with our lesson. I'm going to pass out the worksheet to you. You can work on that. We'll look at some more of these challenging examples tomorrow.